lesson, we're going to look at one of the most basic economic concepts. In fact, the concept we're going to study today forms the very basis of the field of economics itself. So we're also going to define economics as a science once we have discussed this basic problem. So at this point in your course, you may have already learned what the basic economic problem is, that very problem which gives rise to the field of economics itself. The problem that economics focuses on is that of scarcity. Now, what is scarcity? Something is scarce if it is both desirable and limited. Now, what is meant by desirable? This basically means that people want it. People demand it. It serves some benefit to people, to society. So something is scarce if it is desired or demanded, but limited in supply. Now, why is this a problem? The problem that economics focuses on is scarcity itself, because humans' wants, and in some cases their needs, are for all intents and purposes infinite. In other words, there is no limit to how much humans really want. But the resources needed to meet those wants are limited and scarce. This gives rise to the field of economics itself. Economics is simply the study of how to deal with the problem of scarcity. In other words, economic systems are those systems which allocate society's scarce resources between the competing wants and needs of society. Now, this basic economic problem of scarcity gives rise to a second concept that we're going to focus on today, which is that of opportunity cost. So because resources are scarce, choices must be made in how to allocate them between society's competing wants and needs. Anytime a choice is made about how to use a particular resource, what happens is that something must be given up. So the opportunity cost of any decision about how to use scarce resources is what could have been done with the resources that are being allocated. Now that's a quite complicated way of saying a very simple thing here, and that is that the opportunity cost is the opportunity lost. It's what we lose out on. It's what we miss out on when we decide how to use a particular resource. Now this could be as simple as a garden plot. Imagine you have a garden in your backyard in which you can either plant carrots or lettuce. If you use that land to plant carrots, the opportunity cost is the lettuce that you could have had if you had planted lettuce instead. In today's lesson, we're going to focus on something even more basic than a garden. We're going to talk about time. Time is a scarce resource because we all wish we had more of it, yet it is clearly limited in supply. You must decide how you use the limited amount of time you have in a particular day, and the decision that you make has an opportunity cost associated with it. The opportunity cost is what you could have done with your limited amount of time had you chosen some other activity. Let's assume, for example, you have 16 hours in a day to decide whether you will work or play. So we're going to assume that you have 24 hours in a day, but you sleep for 8 of them, leaving 16 left over, during which you can either work or play. So in a 16-hour day, you must make decisions about how to allocate the scarce resource of time. Now those decisions and that allocation, the different choices you have to make, can be shown on a very basic economic graph. So that brings us to the production possibilities curve. This is a basic economic model which shows the trade-offs society or an individual faces in how to use scarce resources. So this model, the production possibilities model, we're going to look at one now using our example of time. Assume that, as we said, you have 16 hours in a day. So the graph on the right here is going to show what you can do with your 16 hours, assuming you have two choices. You can either work or you can play. So to illustrate these trade-offs, we must label our production possibilities curve with those two options. You can either work, which we're going to put on the vertical axis here, or you can play, which we will put on the horizontal axis. Now, what is the most amount of time you could spend working in a day if you had 16 hours in that day? Well, you could clearly spend up to 16 hours working. So we're going to put a 0 here for our origin, indicating that you are spending 0 hours working and playing. And then we're going to label each of the points along this graph with the number of hours spent working and the number of hours spent playing. Up to 16 hours of work and up to 16 hours of play. So if you chose to spend 16 hours working, you would be producing at a point which we will call point A on your production possibilities curve. On the other hand, you may have chosen to spend 16 hours playing in a day, which would put you at a point down here on your production possibilities curve. We'll call this point B. Now let's be realistic here. It's highly unlikely that you would spend 16 hours working in a day. It's also unlikely that you would spend absolutely no time working and 16 hours playing. So what we have is a line connecting these dots, which illustrates the different combinations of work and play that you have to choose from in the 16 hours during which you are awake in a particular day. So let's look at some other possibilities along this PPC. You could spend 12 hours working, which would leave you with 4 hours for play. So a point such as point C is clearly possible. This would be a long day of work, but you would still have 4 hours of play. On the other hand, you could choose to spend more time playing, let's say 12 hours, and only 4 hours of working. This is also clearly possible. As you can see, it lies on your production possibilities curve. Any point along this curve is possible. For example, you could spend 8 hours working and 8 hours playing. A healthy balance. We can call that point E. All of these points are on an individual's production possibilities curve for work and play in a 16-hour day. But what if an individual wished to spend 10 hours working, but also spend 10 hours playing? What we see is that such a combination of work and play lies beyond the individual's production possibilities curve. I'll call that point X. Now, to have 10 hours to work and 10 hours left over for play is clearly desirable. This point X, is desirable, but given the 16-hour day, it is impossible. That brings us to a very important point about the production possibilities curve. A point beyond an individual's or a nation's or a business's production possibilities curve is not possible. That's the whole point of the curve itself. It shows what is possible in our use of our scarce resources between two competing wants and needs. Of course, in this case, playing is something we want, working is something we need to do. Now, what if an individual only spent 6 hours working? We'll put a point down here at 6, but also spent only 6 hours playing. What does a point such as Y, we'll call that point Y, what does a point such as Y say about our production possibilities? If an individual chose to spend only 6 hours working and 6 hours playing, it's clearly possible, but undesirable. A point such as point Y would represent an inefficient use of an individual's time. This is also therefore considered inefficient because somebody who spent only 6 hours working and 6 hours playing would have an additional 4 hours of complete downtime. This may sound appealing to some, but on the other hand, it's considered inefficient because it's not being put towards productive use, considering play and work are both productive uses of time. So the production possibilities curve, this is the most basic of economic models. It could be a straight line such as that which we see here. Now the reason the PPC for our 16-hour day is straight is because the opportunity cost of an hour of play is exactly 1 hour of work. Let me show you an example of this. Let's assume that yesterday you did spend 16 hours working. You woke up this morning, decided that was a bit overkill, so you decided to tone it back and spend 4 hours playing today. In other words, you're going to move from point A to point C along your production possibilities curve. Now, was this decision free? In other words, did this decision cost you anything? You may say, well, sure, it's free because I didn't have to spend any money in order to spend those 4 hours playing. However, in economics, free does not refer only to the monetary cost of something. Nothing is free as long as there is an opportunity cost associated with it. So the question is, what was given up in order to move from point A to point C? What was given up? And the answer is 4 hours of work. Okay, so this is our opportunity cost here. The opportunity cost can always be seen along a production possibilities curve as the opportunity lost. By spending 4 hours playing, the individual lost the opportunity to work for those 4 hours. Now, assume 4 hours of play is not enough, so you decide to play for 8 hours, and you're going to now move from point C to point E. Again, the opportunity cost is another 4 hours of work. In this case, with a straight line production possibilities curve, the opportunity cost of 1 hour of play is always 1 hour of work. It's what must be given up. Moving from point E to point D, we can see that 4 additional hours of work is sacrificed. There is a constant opportunity cost along this production possibilities curve. Now it would work in the opposite direction as well. If you wish to spend more time working, the opportunity cost is the benefit, the enjoyment you could have gotten from an hour of play. 1 hour of work equals 1 hour of play. That tells you the opportunity cost of work in this example, or the opportunity cost of play. So this lesson taught us the basic economic problem of scarcity, which says that in a world of infinite wants and needs and scarce resources, we have a problem. We face trade-offs, and economics is the very study of how to deal with that problem of scarcity. Economic systems seek to allocate scarce resources between society's competing wants and needs in various ways. Throughout the course, you're going to learn all about the different ways that resources can be allocated between humans' infinite wants and needs. But one thing to keep in mind is that there is nothing free in a world of scarcity. If you want more carrots, you must give up lettuce. If you want more play, you must give up the benefit you could have gotten from work. In a world of scarcity, something must always be given up in order to have something else, and that is what opportunity cost is. It's what could have been done with the resources needed when you make a particular decision. The opportunity cost is the opportunity lost. And the production possibilities curve, this is the most basic model in economics. It simply shows the combination of goods or activities that an individual or society can have given the scarce resources available. It is impossible to have more than what is achievable by our production possibilities. Wouldn't we all love to have 12 hours of work and 14 hours of play? What a great day that would be. You could get a lot of work done but still have even more time for play. However, points like point X are unachievable, yet highly desirable. On the other hand, a point such as point Y represents an inefficient use of our resources. To only spend 6 hours working and 6 hours playing, you're basically missing out on 4 hours of work and play. However, any point from point A to C to E to D to B is possible and represents an efficient use of our time because it is being used to either work or to play. So that wraps up this first lesson in economics. In future lessons, we're going to look at more realistic production possibilities curves for nations. When a nation has to choose how to use its land resources, its labor resources, and its capital resources, it faces trade-offs just like you do when you decide how to use the limited amount of time in a day when you wake up in the morning. Thanks for watching.